Welcome to RichPlanet TV. I'm Richard D. Hall. Earlier this year I interviewed Andrew Johnson to tap into his vast knowledge of the Apollo missions and also the evidence of life on Mars. Now today I've returned to speak to Andrew, who's going to teach us some more information about our solar system and beyond. Welcome, Andrew Johnson.
Thanks for inviting me back, Richard.
Okay, now we covered the Apollo missions and Mars, as I mentioned in previous shows, and our assertion is that we don't believe that NASA have been honest about what's really up there. Now we're going to talk about some more objects within the solar system, specifically comets and asteroids and this kind of thing, because you ask a mainstream scientist what is a comet or asteroid, they'll come out with a standard model or a standard view of it, and
right.
you think that it's not quite as clear cut as some astronomers might think. But before we go into comets, asteroids and other celestial bodies, for example, some people allege planets in our solar system that aren't known about, can you go through just a description of the solar system, starting from the sun, working outwards, just to give people an idea of the sizes? I know it's quite a difficult thing to describe in 5 minutes, but...
Yeah, well, I don't think it's too bad. I mean, one of the things that struck me when you know, I started looking into this area of astronomy and some of the cover-ups, and as you said, the things that we've already discussed, was that you know, I've been interested in astronomy for a long time, and I seem to have, you know things that other people don't seem to know, which is things like the sizes of the things in the solar system, the relative distances. And I think without that basic knowledge, you're much more prone to being subject to victims of disinformation, right, which hopefully we'll get onto later. But so one of the key things that you can think of in helping to get a grasp of the size of the solar system is the distance between the Earth and the Sun. Right, and many people, you know, will have a rough idea of what that is, but others don't, and the rough distance is 90 or 100 million miles. It averages at about 93 million miles. So we're going around the sun in a circular orbit, and we average at 93 million miles away from the sun. Now, all of the planets, you know, at different distances from the sun, we have Mercury the closest, Venus is the next closest, often described as kind of a sister planet to the Earth because it's about the same size. Then we go out to the Earth, then to Mars, and then in between Mars and Jupiter we've got the asteroid belt, and then we've got Jupiter, Saturn, and then we've got Uranus and Neptune and Pluto. So those are the 8 planets in the solar system. They used to class Pluto as a planet.
Just to quickly interject, Andrew, am I right in thinking that all of the planets go around the sun this way, but Venus goes around the opposite way?
That's not quite correct. The planets all orbit the sun in the same way, but the orbit of the planets rotating on their own axis, their actual day, Venus has a motion which is called retrograde. In other words, Venus's spin is the opposite to the other planets, which is very curious, because if you think of the physics involved, you know, we've both studied physics to some degree, and we have this thing called angular momentum, and when you fire something which is spinning, or something which is spinning that breaks up, or something that is spinning changes its motion in some way, angular momentum is always conserved. So if the theory about how the solar system was formed, where they allege it's formed out of a rotating disk of material, you know, so it should all be rotating the same way. So for one planet to end up spinning the opposite way to all of the others, that's quite unusual. That you know, that's not easily explained by the standard.
So it doesn't go around the sun the opposite way?
No, it goes round on its axis the opposite way.
On its axis.
Yeah,
okay.
correct.
So if we say that 93 million miles is one unit, one astronomical unit,
yes,
how far are we talking about to Pluto, to the last?
I think it's about 40 astronomical units,
right,
around about that sort of figure. It's about 4 billion miles away. So in other words, one astronomical unit is roughly 100 million miles. So you know, 1 billion miles is approximately 10 astronomical units.
Right, and now there are a couple of other planets, or planetoids, do people call them? Because Pluto is not a true planet, is that?
Well, they used to class Pluto as a planet up until, I can't remember when the ruling was made, but it was about 5 or 6 years ago. They decided that Pluto was too small to be called a planet, so they've characterized it either as a planetoid or a dwarf planet.
Right.
And I think you'll see both those terms used. And Pluto is actually smaller than our moon. They've now got a much better measure of its size, and I think it's about 1,000 miles in diameter, and I think the moon is like 1,400. I can't remember the exact figures off the top of my head, but it's round about those sorts of figures.
Right. So are there any other planetoids other than Pluto?
Again, that's something that seems to have been detected in the last 10 years and more. We've had several named planetoids which mainly have been detected by studies that NASA have done. One is called Sedna, that was talked about in 2003, and I think that's around about 1,000 miles in diameter. And then we have Eris. We can show some graphics of these from the websites and so on. And then we have Maki as another one, and these are all way out beyond the orbit of Pluto, so they're a long way off. And I think one of them, Eris, is 800 miles across. So these are relatively small objects. They're smaller than Pluto, but they're a long way off.
So how many times further than Pluto away from the Sun?
The Sedna planetoid, or the dwarf planet, it's 3 times further away than Pluto. So it's approximately 12 billion miles from us. It's a long way off, and the diameter is about 1,000 miles.
Right. All right. Now, within the solar system, we have other belts or bands. One after Mars, and then another one right at the edge of the solar system. Can you tell us about those, Andrew?
Right. So basically, we have the asteroid belt, which we can be fairly easily observed. I mean, even if you have, for example, a small telescope, you can't see it as a cloud of debris. But you can, for example, see some of the larger asteroids. There's Ceres and Pallas are 2 of the larger asteroids, which I think if you've got a good telescope and you know where to point it, you can actually see those through a telescope. Right. And they're between the orbits of Jupiter and Mars.
And there are thousands of asteroids.
Yeah, there are thousands of asteroids. I don't know how many they've catalogued, but there are several thousand, I think, that have got names.
Right. And do these asteroids all rotate in the same orientation as the planets?
I'm pretty sure that they do. I don't think they would be orbiting in counter direction, because there would then be too many collisions.
Right. But this zone, it's spread over a huge area.
Yes.
Between these 2 planets.
Yes.
All
yes.
Right. And does it extend within the orbit of Mars or within the orbit of Jupiter, or is it contained?
It's contained within a relatively narrow band. I don't know what the exact width would be, but you're talking, probably a few thousand miles to maybe a few tens of thousands of miles. I don't think it's much wider than that.
And I would say that the most obvious thing which would spring to my mind would be, well, were those asteroids once a single solid planet? And we'll come on to that.
We'll mention that, and some, the argument has always been, as I've understood it, is it from the asteroid belt from a planet which broke up, or from one that never formed? Right. So is it some leftover material that started to accrete into a planet and then failed for whatever reason? Now
we have a belt further out as well. Tell us about that.
Yes, these again are sketchy in my knowledge. And one is the so-called Kuiper belt, which again is meant to be something like the asteroid belt, but I think the Kuiper belt is more theorized. They can't directly observe it, I don't think, to my knowledge. It's only they've inferred its existence from the motions of various bodies which they think have come from that region of space. Right. And then out beyond that, which is said to be some kind of limit to the solar system, is the Oort cloud. That's O-O-R-T, the Oort cloud, proposed by Jan Oort, who I believe was a Danish or a Dutch astronomer, and he suggested that was where the leftover material, which was around when the solar system formed. We've got this cloud of material which is like a sphere around the disk of our solar system. Yeah.
All right. Now, one term that I've heard used is the history of the solar system, which I think is quite relevant to what we're going to talk about. And one of the things that astronomers look at to try and determine how the solar system formed and what its history was is comets. Just tell us about comets. How common are they? How many are there? How big are they? What are their orbits? How far away are they? Just give us a background on comets.
Yeah, well, this is again the excitement over Comet Ison, which was recently seen in our skies very briefly. there was lots of excitement about that, and they're claiming, as you say, you know, that if you look at the comets, you can calculate certain things about them, you can observe certain things about them, and that will then teach you about the early solar system, because the basic idea is that comets are from the cloud of material which from which the solar system formed,
right,
you know, aeons ago, you know, billions or hundreds of millions or billions of years ago.
Yeah.
And so the idea is that if you see a comet coming in, you know, you get your telescope on it, or you do a spectrographic analysis of the tail, and you can see what chemicals are in the comet, and therefore you can see
right,
what chemicals are in the early solar
right,
system and stuff like that.
So a spectrographic analysis is measuring what frequencies of light are within that the comet is giving off, and scientists know based on the frequency what elements
that's right
are in there. Okay,
that's right.
We'll come on to that. But what about the orbit of comets? Just describe how they're different to planets.
Yeah, well, planets have roughly circular orbits, or very close to circular orbits. Most of the planets do. Some of them are slightly less circular than others, but in the main they're circular orbits. Comets, however, generally have an elliptical orbit, you know, which is like an oval shape, and they tend to spend most of the time way out in the solar system, but then they come in, when they come into the solar system, they rapidly accelerate, and then they get you know, they come around the sun, and you know, they speed up.
So it's it will be kind of like this,
like a slingshot. Yeah,
and then it's come around like that.
Exactly.
So there's a lot more forces are at play as it's going around the back of the sun and then back out again. So as you say, like a slingshot.
Yeah, you can get the slingshot effect.
Okay.
And the thing that's we'll probably mention once or twice as we go through this is perihelion, which is where the comet is closest to the sun. Perihelion, helion being the sun, and peri, I'm assuming, means closest or close approach. Right.
So there are various popular comets that people will have heard of, such as Hale-Bopp, Halley's Comet, Ison, Elenin. These are names of comets that have come past in the last sort of 20 years.
Right.
But what's the sort of magnitude? I mean, how many comets are there going around the sun in 1 year, say?
Oh, there are quite a number. I mean, again, the place to go and look is the Minor Planets Centre. So if you Google that, we'll probably be able to get the website, you know, on the screen here. But if you go and look on there, they keep track of all the comets that have been discovered, and this is a very important sort of concept that people need to get to grips with. In that there are, you know, we've got, as you said, people have heard of Comet Halley, they've heard of Comet Hale-Bopp, and amateur astronomers, you know, they get a kick out of having a comet named after them. That's their goal, is to get, you know, one of these celestial objects named after them. It's quite an incentive, you know, if you can get something that comes around the sun named after you. So they've got thousands of pounds of equipment which they use to try and detect these comets. And so, for example, when I last looked at the Minor Planets website last month, I had looked at it in about the second week of November, and they'd already discovered 3 new comets just in that month.
So what would be the difference between a comet and a near-Earth object then?
Well, a comet would normally, I think, you know, comet doesn't come within the orbit of the moon, for example.
Right.
If an object came within the orbit of the moon in distance, and the moon is only like 200,000 miles from us, again that varies slightly, then that would be classed as a near-Earth object. I don't know whether there's a cut-off figure which distinguishes between a comet and a near-Earth object, whether they say if it comes within 1 million miles, then it's a near-Earth object.
An asteroid presumably is one within that particular belt in a circular orbit.
Yeah, allegedly. But again, you know, as we've got a couple of slides where it seems that asteroid can behave like a comet.
Right.
So
and possibly an asteroid can become a comet.
Yeah, potentially.
Right.
Potentially.
All right. Now, there's quite a lot of probes gone near or crashed into and sent data back from various comets over the years.
Right.
So, because there is a bit of argument over what a comet is made of, am I right?
Right. Well, that's one thing we haven't really spoken about yet, and again, it is quite important to talk about that, because this is one of these things where, when you start to look into all of these topics, you realise you're being fed a certain set of statements which you're expected to believe. And one of those sets of statements is about comets, because in the before the 1950s, nobody really was quite sure what comets were, and they didn't really have good ways to see how big they were, because what you see when you see a comet is essentially a cloud of dust, and what's generating that cloud of dust, you don't know the actual size of it. It's a bit like if you were to put a balloon around something and blow up the balloon, you just inflate it with air, you wouldn't know how big whatever was inside the balloon was until you pop the balloon, and then you might see it was as big as a golf ball or a football, or it was as big as a pea. You wouldn't really know how big it was. Comets have this bright glowing material around them, and then they have a nucleus within that bright glowing cloud. The cloud of material is called the coma, and then you have the center, which is called the nucleus. So what was proposed by Fred Whipple in the 50s is that a comet is basically a dirty snowball. So in other words, if you imagine you've got this snowball flying around the sun in a highly elliptical orbit, most of the time it's out in the frozen wastes of the solar system, and then every certain period of years, with Halley's comet it's 76 years, with other comets it can be thousands of years depending on the orbit, with other comets it can be as low as 6 years. It comes in, and as the snowball gets close to the sun, of course the snowball melts, the ice turns into water vapor, and then we have this thing called the solar wind, which is like a stream of particles which comes off the sun, and that crashes into the water vapor that's been boiled off the surface of the comet, and then that creates the stream of material which creates the visible tail. That's the standard theory. In other words, a dirty snowball, it's a snowball with dust stuck into it, and it melts as it's coming close to the sun. That's the standard theory.
I mean, the gut feeling with that is it's not going to last very long.
Right, precisely, particularly with those that go very close to the sun and are subject to intense heating. But some of the comets are bigger than others, though. So some of them, their nucleus, the little core of material, can be as small as a mile across. Right. And I think below that size, they probably wouldn't be called comets. They would be called something else. Right. And you probably wouldn't get much of a tail. But the comet Hale-Bopp was around about 15 miles across on the nucleus. All
right, and we'll just hold it there. We're going to talk more about comets and some of the probes that have investigated these comets, and also the electric theory of comets after this. Welcome back. I'm talking to Andrew Johnson about comets. Now, you explained the standard model or the standard theory of comets, that they're dirty snowballs. Now, there's a great deal of contention over this, Andrew. Just to explain why.
Well, I don't think actually there's not that much contention in the mainstream scientific thinking. You get a few people who will say, well, these things can't be correct, but again, I was looking when I was doing research for this latest presentation that I was asked to give because of Comet ISON coming into the solar system. I went onto the GCSE Bite Size, the BBC revision website, and it says, comets are dirty snowballs. Get all
of your best research.
Yeah, of course.
You just go straight there. That's all you need to know.
Yeah, BBC websites where everything that you need to know is, as we both well know. But that just said comets are dirty snowballs. End of story. That's all you need to. That's all the kids need to know. End of. But again, if you start to explore the actual data that's come back from the probes, and that's been one of the killers for me. I was familiar with some of this data. For example, you mentioned a few minutes ago about how we've had. I think we've had three probes that have gone gone very close range to comets. One brought back cometary material with a sample and return mission. Another one fired a probe into the head of the comet, and another one flew. It was actually the Giotto probe as long ago as 1986, which flew towards Halley's comet, and it counted the impact of material before the camera was destroyed by the material being given off by the comet. And they didn't really know at that point what the nucleus was going to be like, and they set the camera to go to the brightest point of the comet. But as they found, the actual surface of the comet was sort of like a dark coloured tarry material, like a bitumen material. Right. which was a bit of a surprise, because that's not the colour of snowballs. I mean, unless it's a very, very dirty snowball, you know, you'd expect it to be a lighter colour with ice.
So am I right in thinking that one of these probes found that there was way less than 10% water?
Absolutely, and this is one of the things they've tried to sort of couch in different terms. Again, if you look at the, in fact, I've got a good quote here. We'll go forwards to that quote.
All right.
Now, on April the 5th, 2002, we had a NASA spacecraft. It flew past Comet Borrelly, and Comet Borrelly, again, was said to have been described as a dirty snowball. But the headline on the NASA's website says Comet has hot dry surface. It has a hot dry surface, and that's what they found. And it says Dr. Lawrence Soderblom of the US Geological Survey's Flagstaff, Arizona station, lead author of a report on the Borrelly flyby results appearing in the online edition of the journal Science, said, "We know the ice is there," he said, "it's just well hidden."
Okay.
So what he's basically saying is, we've got data back from the experiment which shows that we didn't see any water, but we're just going to ignore that because we know that we know that it's ice anyway.
Right.
So that was in 2002, and that was before the Stardust mission. Now the Stardust mission is even more interesting because they sent this Deep Space One probe. This Stardust mission. They sent it to Comet Wild 2, Comet Wild 2, I should say, because it's a German, named after a German guy, and that was in 2004. And that when that got there, the probe was designed such that it collected material which was being ejected by the comet as it was coming close to the sun, and it collected that material in what's called aerogel, which is kind of like a, you know, sort of like blue tack, I suppose. And the stuff, so the particles flying off the comet stuck into that, and then they brought that material back in a capsule, and it landed in the desert, and they retrieved that under, you know, clean room conditions and everything. And they were able to take that material away and actually, you know, do mass spectrometry on it to find out what it was made of. And as is pointed out by the Electric Universe video, which I got a lot of this information from, but it's also on NASA's website. You can go and look at this on NASA's website too. What the particularly interesting thing that they found with the Stardust mission was a material called olivine. Olivine. Now, that's a mineral which is normally found in during volcanic eruption. It comes out of volcanoes, or it's formed during the, you know, the process of either a volcano cooling, you know, the lava cooling, or the volcano erupting then cooling, or within the eruption itself. I don't know exactly when it's formed, but olivine is a mineral. And the thing about it is that if you put it into water, in the presence of water, it will, you know, it will degrade. It will change into something else. It cannot form in the presence of water, right? So they found olivine as one part of the material, but then they found other materials which can only form in liquid water, right? They can't form within ice. They can only form in liquid water. And they actually said, after looking at the Stardust samples that they got back, that the materials that we found are characteristic of planets in the habitable zone of the solar system. Right. In other words, not from the outer solar system.
Yeah, because if we just consider a star or the sun for a moment, if you go a long way away, it's extremely cold,
right,
and certain chemical things can't happen.
All the chemistry slows down with a lower temperature.
So, all right then. Well, let's just distinguish between elements and compounds.
Yes.
We have the 92 chemical elements that everything's made of.
Correct.
Where are they made first, Andy?
Well, we're told that up to the elements iron, if you go up from in the atomic numbers from 1 up to iron, I can't remember what the atomic number for iron is, but all of those elements are formed during the process of nuclear fusion inside the core of a star.
Right.
So we're told that a star is a nuclear fusion reactor, and all the elements up to iron are formed then. But when you go above iron, they have to be formed by different processes because they can't be formed in a nuclear fusion reactor. And we're told that those elements are formed in supernovae explosions, when you have much greater forces of the star exploding, and these elements are then formed during the explosion.
So you have certain elements, and then as they come to within certain temperature regions, you call it the Goldilocks region, of certain molecules can then be formed.
Right. Well, that's true. But we're getting then away. We're now into the situation where the star is stable.
Right.
We've got an ongoing reaction of, for example, fusing hydrogen into helium, which is allegedly what's going on in the sun right now, and it gives us all our energy. That's what we're told. And that process then creates heat and light and radiation. And around a star, you have planets which can then soak up that heat. There are other chemicals on those planets which then start reacting with each other and form these various compounds, like they form water, for example, from hydrogen and oxygen, and they would form methane, for example, from carbon and hydrogen, and they would form things like carbon monoxide and carbon dioxide. So those are all formed as a result of chemical reactions rather than nuclear reactions.
All right, so tell us what the standard model for comets is and why the accepted theory suggests that there shouldn't be certain elements and molecules on a comet.
Right, so the standard model is basically that a comet is some bits of dust stuck into a ball of ice. So primarily, according to what they say, is if you were to fly to a comet, you should primarily find ice. When you get there, you crash something into it, you should ice and water vapor should come off.
And where do they say this ice came from?
Well, they say this ice came from the Oort cloud, because there was a cloud of material left over from when the solar system was formed, and that just contains leftover bits of dust and water, which is hydrogen and oxygen combined. Right. That's the standard sort of model.
Right.
And you obviously you're going to, or according to them, you're going to get things stuck into the snowball, which are just other bits of rock, bits of compounds that formed when the solar system was formed from the whatever process formed it. They get lodged into the surface of the snowball. That gets carried into the solar system when the comet comes around, and so by watching the comet melt, looking at that material, you should be able to tell what sort of materials were there, according to them, in the early solar system.
Right.
So the basic thing we're trying to get to, I suppose, is that it is assumed right down the line that the only thing that comets are a result of is a formation of the solar system, right? So that's the kind of idea they want to keep you fixed on. Right. We don't want this idea that comets come from somewhere else, or they're formed by some other process which has little or nothing to do with the formation of the solar system.
Right. So is it suggesting that we had planets formed, and then maybe there was a massive collision which created loads of little bits, and they are comets? So comets maybe used to be part of a planet. Is that what it's suggesting?
Well, they're not suggesting that. NASA and the mainstream astronomers are not suggesting that.
Right.
It's several groups of people. One group is the David Tolbert and Wallace Thornhill, who've been working on the electric universe model since about probably for 10 or 15 years now. I first became aware of it in 2004. So they would contend that you can't say for sure that the comets are from the early solar system. They're not a result of leftovers of the early solar system. They think that at least a number of the comets, not necessarily all of them, are formed as a result of the breakup or partial breakup of planets in the solar system.
Right. All right. Now, just to come on to the electric theory of comets and the universe, let me just, because this is fairly new to me, some of the data that come back from these probes is suggesting that the comets have an electrical charge.
Right.
Just expand on that.
Right. So with standard astronomy, the solar system is electrically neutral. There's no overall charge, within the solar system. And there are no particular electrical interactions between the sun and the planets. It just doesn't happen. It's just all we have is basically heat exchange. We get heat from the sun, ultraviolet radiation, and so on. You get the odd bit of phosphorescence, like the aurora borealis, for example, is allegedly a kind of phosphorescence.
Right. And other than that, they're obeying Newton's laws of gravity and motion.
And so the solar system is driven by the gravitational force, or that's been sort of morphed into relativity, which is slightly different. But essentially, gravitation still explains the motion of the planets and the solar system.
Describes, I would say.
Yeah.
Not explains.
Yeah, describes. That's probably a better word. So the idea that the electrical charge plays any significant role in the way that the solar system works, or in the solar system, or in the processes that go on in the solar system. That's generally regarded as just a sort of fringe theory.
Okay. So why did one of the probes? Why did the data suggest that there's some huge electric charge around one of these comets?
Well, one of the key missions was the 2005 mission to Comet Tempel 1, which was the deep impact mission. Now, what they did with the deep impact mission is they wanted to fire a projectile at the comet from a probe, and then film that projectile crash landing into the comet's nucleus, and see what happened. And interestingly, as somebody pointed out to me when I was speaking about this, and I didn't really think about this initially, they actually fired a copper probe into the comet. And it makes you wonder why they chose copper as a material, which I think it was an 800-pound probe, and that's got to be very expensive to put 800 pounds of copper. It's not. I mean, it's not beyond the realm of a space mission budget, of course, but it's still an expensive amount of copper, 800 pounds, to put into a probe to fire into the comet. Why was it copper? Why didn't they just use a lump of rock or something to see how the rock fragmented? But no, they chose copper. They probably had a reason for that. But what actually happened when they did that was, as this projectile approached the comet, and the projectile actually had a camera built into it, so they were able to film the approach to the comet, and they've got a time-lapse video of this, which is on their website, on NASA's website, and they basically saw a discharge, momentary discharge just before this probe impacted the surface of the comet, and the brilliance of the flash was probably 5, 6, 7, 8 times brighter, and all the NASA scientists were, wow, we didn't expect it to do that. This is much more energetic than we thought it would be. And also there was very little of a crater. There was hardly any crater. They claimed there was going to be a big crater, but there wasn't. Which, of course, if this thing was mainly snow and ice, an 800-pound copper thing travelling at, I forget the velocity, but it was several tens of thousands of miles an hour, would make quite a significant crater in a ball of ice. It wouldn't, because the heat from the impact would melt it, and all kinds of stuff would come flying out. That really wasn't seen, not to the degree that you'd expect. But the Electric Universe guys, particularly Wallace Thornhill, as the probe was approaching on the day that he knew that this mission was going to impact the comet, he made these predictions, and he lists them on his website, and they said that there would probably be not only an electrical discharge momentarily before the probe hit. He also said that the electronics from the probe would experience interference because of the electrical charges.
Electric field.
Yeah, the electric field, exactly. And that's exactly what happened.
All right. Well, so if we've got a huge charged object flying through space at speed, that's what an electric current is. Something which has charge, which moves.
Right.
It is current.
Right.
So we've got kind of a current flowing through space then.
Right.
Really. So, and if that were to fly through a magnetic field, it will change its motion. If the sun emits high levels of radiation, which it does, would that affect something which is charged?
Well, I don't think the radiation would, but you make a good point about the electrical field and the magnetic field. The sun has a magnetic field, so
right.
I don't know. I've not studied the electric universe theory to see if there are small perturbations in the orbit which are actually a result of the interaction between the electric field of the comet and the magnetic field. I don't think. You may find that the effects are not as strong as that.
Right. And what about the actual tail? Or do the electric universe people say that the tail is due to an electric effect?
Yeah, the tail. Well, I think what they basically say is that obviously you're going to get some heating. Some of the effect does come from heating, but the fact that you don't have much water means that the way that the cloud is formed has to be explained in a different way. So the cloud is actually of the tail is formed probably by the electric fields of the object and the sun interacting, where you get the solar wind, which is a stream of charged particles. Those charged particles hit the comet, and they will charge up the field around the comet and cause various effects, one of which is the formation of the tail, and that field helps to keep the tail contained in a particular shape in most cases.
Right. So, have they not examined the orientation of the tail to say, well, hang on, that can't be purely but the result of a Newtonian reaction, that it's travelling at speed that way, therefore the tail would be immediately behind it? Does the tail deviate? If you see what I mean?
Well, the tail can deviate because particularly this became particularly obvious with Hale-Bopp. I'm not sure if the Electric Universe guys have actually explained, for example, Comet Hale-Bopp. You can see that Comet Hale-Bopp has two tails, a gas tail and a dust tail. You can clearly see that if you go and look at the images. So it's quite possible that their explanation would involve the way that the electric field is formed around the comet, and that's what causes this. Now
I know that well, when I spoke to Lloyd Pye, he said that he was a fan of the electric universe theory. So why would it be that your average astronomer or cosmologist or physicist even maybe would reject the idea of forces due to electric effects in the formation of the solar system and the universe? What's the contention over it? Why is it such a hot potato?
Well, I'm not quite sure overall, but again, we could imagine that it's something to do with the way that we might derive energy, because if the solar system is more energetic in the sense of an electric field and so on, it may raise questions about various energetic processes that are going on in the solar system and having to have a different explanation for them. So that could be part of it, but I think it may in this case just be down to laziness. In other words, if you realise that many of the fundamental sort of equations that have been worked out are actually they're only approximations and they're not accurate enough, then you're going to have to rewrite a lot of the textbooks, and you're going to have to let go of a lot of the original research and replace it with something else.
All right then, Andrew, we'll continue with the electric universe theory and comets after this.
Which is the formation of the tail, and that field helps to keep the tail contained in a particular shape in most cases.
Right. So, have they not examined the orientation of the tail to say, well, hang on, that can't be purely but the result of a Newtonian reaction, that it's travelling at speed that way, therefore the tail would be immediately behind it? Does the tail deviate? If you see what I mean?
Well, the tail can deviate because particularly this became particularly obvious with Hale-Bopp. I'm not sure if the Electric Universe guys have actually explained, for example, Comet Hale-Bopp. You can see that Comet Hale-Bopp has two tails, a gas tail and a dust tail. You can clearly see that if you go and look at the images. So it's quite possible that their explanation would involve the way that the electric field is formed around the comet, and that's what causes this. Now
I know that well, when I spoke to Lloyd Pye, he said that he was a fan of the electric universe theory. So why would it be that your average astronomer or cosmologist or physicist even maybe would reject the idea of forces due to electric effects in the formation of the solar system and the universe? What's the contention over it? Why is it such a hot potato?
Well, I'm not quite sure overall, but again, we could imagine that it's something to do with the way that we might derive energy, because if the solar system is more energetic in the sense of an electric field and so on, it may raise questions about various energetic processes that are going on in the solar system and having to have a different explanation for them. So that could be part of it, but I think it may in this case just be down to laziness. In other words, if you realise that many of the fundamental sort of equations that have been worked out are actually they're only approximations and they're not accurate enough, then you're going to have to rewrite a lot of the textbooks, and you're going to have to let go of a lot of the original research and replace it with something else.
All right then, Andrew, we'll continue with the electric universe theory and comets after this. Welcome back. I'm talking to Andrew Johnson about comets, and we touched on the electric universe theory. Can you, because I still don't have my head around this electric universe theory, Andrew, can you give us in a nutshell, what is the electric universe theory?
In a nutshell, the electric universe theory says that electric force, electric fields, electric forces play a much greater role in the formation of structures we see in the universe when we look around,
right,
than is now acknowledged. And David Talbot and Wallace Thornhill, who looked at this, they based this on observation, in that they've seen, for example, plasma formations when you use electrical discharge in combination with gases. Mm-hmm. Right, so you pass electrical discharge in various ways with various fields through chamber full of gas,
yeah,
which is, and then and you heat up the gas so it becomes plasma. And when you get the plasma is charged, so the charge within the plasma reacts to the electric field. It's influenced by the electric field, and they say that the plasma formations that you can create in the laboratory match, in many cases, large-scale structures in the cosmos,
right,
like there's the Helix galaxy, or the Helix formation, mm-hmm, and the Hourglass Nebula, for example. These all look like plasma formations where you've got electric fields in certain orientations, which are then causing the gases to flow and produce certain shapes of clouds. Mm-hmm. And they've got many examples of this.
So let me just interrupt that, Andrew. So are they saying that your standard astronomers and cosmologists, they've got it completely wrong? Is that what they're saying?
Yeah, well, I don't know if they say they've got it completely wrong, but they're saying that they make one of the basic points that they make, for example, is that if you look at the electromagnetic force, it's something like 10 to the 24 or 10 to the 34 times more powerful than
right,
the gravitational force.
Right.
So how is it that such a weak force, according to standard theory, can give us most of the form and shape in the universe,
right,
when the stronger force, the electric force, is not giving us anything at all, according to the standard theory? That's one of their basic observations.
Okay, Andrew. Well, I don't think we're going to solve how the solar system was formed just in this conversation. It's a huge question. But let's go on to look now at some of the craters on Earth that still exist from comets which have impacted, because this is another area that's been used to create fear, perhaps,
exactly,
in films like Deep Impact and things like that. So what's the likelihood that a disaster could occur?
Well, I mean, yeah, let's talk about that, because that's again one of the reasons why I've put this presentation together, because every time we get a comet comes into the news, as was with Hale-Bopp and Comet Elenin that we've mentioned, we'll probably talk a little bit more about that later. Comet Elenin was in 2011. You go onto the internet and you get many websites saying, oh, the comet's going to crash into the Earth, it's the end, yeah, stock up with water, buy your water filters, buy this, buy that, buy your radiation suit, etc. And so that's comets are really good for generating fear, as you already said. So but it is true, in that if you go around the Earth, and I wasn't sure of this until recently, on the surface of the Earth have now been determined that there are 184 impact craters, mm-hmm, and some of them are quite big. Some are several miles across. Right. The really, I think the most famous one, which the first one I ever heard about when I was a kid, is Meteor Crater in Arizona, and that's got a tourist centre next to it, and it's about a mile across. It's 500 feet deep. I think it's 50,000 years old. I think it's relatively recent, and it has to be, because the surface of the Earth, it's still there, because obviously the surface of the Earth gets weathered, it gets eroded, the climate changes, and so on.
So these are all relatively young impact craters because they're still there?
Well, most of them are relatively young. I mean, again, the ages vary, but I think you can see the ones that are more weathered are the ones which are older, obviously, and more eroded. So some of them are covered up, and the oldest one they found is in the Yucatan, which is the land has kind of moved over it, and the land has reformed, and that was the one that was allegedly where the impact that wiped out the dinosaurs was, and that was, I think, 65 million years ago.
So it is possible that we could be hit by something which could affect life on Earth, then, you think?
Oh, absolutely, and in fact it's already happened. I mean, earlier this year in February 2013 we had the impact over Chelyabinsk, or rather not an impact, it was an airburst over Chelyabinsk. That was a reasonable sized object. Several thousand people were injured because of flying glass. You know, windows were blown in, and there was a factory wall fell down. So that was some quite significant damage, and it was across a relatively wide area. And the one which I put into this presentation when I was asked to give this was the Tunguska event, which happened in 1908, and they're still not quite sure what that was, but it was flattened an area of about 200 square miles of forest.
Well, some authors have suggested that was not natural.
Right, they've said, suggested various things: a nuclear bomb, Tesla's beam weapon, an exploding flying saucer or something.
Yeah. Well, and then we've got, you also mentioned in your presentation, the alleged comet of 562 AD, which Alan Wilson is quite keen to talk about. Right,
and of course Alan would probably do a much better job of talking about that than I would. But the thing that intrigued me was the vitrified hill forts that I think you were going to go and film there, weren't you, at one time?
We were.
And I'm quite curious about that, because there was also, I came across a report from Italy of an impact in Italy, and that was dated also to about 500 AD or 560 AD. So it appears there is a significant amount of evidence for some type of catastrophe, of reasonable sized catastrophe. And as I think Alan Wilson said, England was uninhabitable for about 7 or 11 years.
Yeah, so that's what Alan claims, and he claims that helped end one of the, you might call it the true British reign, of the original British, and the Saxons then came along and effectively just walked into an empty country, and it wasn't taken by force, as is suggested in the history books, for example. So, a hugely contentious issue, but that's Alan, puts a lot of. He thinks that event was extremely important in changing the direction of British history in 562 AD.
Right, and of course I'd add on to that time, as I understand it, was called the Dark Ages, and indeed that's what it would have been.
Yeah. All right. Well, just to mention that. There is actually something, they call it the Space Guard Centre, and that's in Knighton in central Wales, or it's in mid Wales. It's on the border, England-Wales, and that was put up in the 90s, and I've been there. I've got some film footage of this, and its job, allegedly, is to look for near-Earth objects. They've got a couple of domes there with telescopes in them and what have you. But I know a researcher who thinks that it's actually a cover, and that it's not looking for near-Earth objects. I don't know this to be true. This is
it's looking for near-Earth objects, but not rocks.
It's looking for near-Earth objects, but they're actually on the Earth.
Right.
Yeah. Animal mutilation cases, possibly. I mean, we don't know that, but it seems that there is a military connection with this Space Guard Centre, in that the person who managed to get permission and funding to build it is ex-military. So I went there, and there's a very interesting stone circle which was put there in 1997 called the Diana Circle, obviously after the death of Diana. It's a stone circle, 24 stones I think, and in the centre is a huge silver like chrome ball fixed to the ground with a chain. Now what that's for I don't know, but to me, are they really looking for near-Earth objects at that place, trying to save the planet? Possibly, but possibly not, in my opinion.
No, I mean, I think spaceborne systems would be far more effective in doing that these days.
And a lot of these objects seem to get discovered by relatively amateur astronomers.
Correct.
So can you tell us about that, Andrew? Because this applies with the ISON comet. We just want to.
That's correct. Yes, I mean it's very important to understand the role of amateurs, because you and I have spoken at length about how NASA has covered things up, and I think they're covering a lot of stuff up. But
just to interject there, Andrew, one thing that you can't cover up is the sky.
Yes. Yes, I mean that's right. You can't cover up people's own observations of the sky, but of course many people hardly even look at the sky. So if you go around telling them what's in the sky, and they never bother to look for themselves, then you can create a false impression of what's there or what isn't there.
Yeah. So ISON, is there any points you want to make about that before we come on to Planet X?
Right. Well, yeah. Well, Comet ISON, I mean, is a prime example because that was discovered by 2 amateur astronomers. The thing partly why I went through the explanation of the size and scale of things in the solar system is because of the way that comets are discovered by amateurs, and you've got some quite advanced equipment now. Comet ISON was discovered in September 2012 by 2 Russian astronomers. Now, admittedly they were working as part of an organised group, a well-equipped group of amateurs.
So that's about a year before it got anywhere near Earth.
Yes, correct. It was about a year before it was close to us, and they discovered it with a relatively small telescope. I think it was about roughly 1 metre telescope.
So interject again, Andrew. So can I take it from that then? If there is going to be a reasonably big object which is going to affect the Earth and hit the Earth, someone's going to find it first. With a lot of warning. Yeah,
that is precisely my point. Now, if you go onto that Minor Planet Centre, you'll see that they get thousands of observations logged on there per month. There are many amateurs around the planet in competition with each other looking for these comets, and we have to mention how the size of Comet ISON when it was discovered. When Comet ISON was discovered, it didn't have a really great tail behind it. It was a little tiny blob on a photograph. We've got an image of the discovery of how they discovered it. Right. They saw this little tiny dot on their image move, from one place to another on their image, a distance of, maybe 20 or 50 pixels on their digital image, and that was taken 30 minutes apart. So they knew it was moving at speed. And that object is 2 miles across, and it's out beyond the orbit of Jupiter when they discovered it.
And it was spotted by amateurs first.
And it was spotted by amateurs first.
So there you go.
And they're doing it all the time. They're doing it all the time. They have special telescopes which are computer programmed. They track portions of the sky. They put in go-to coordinates. They take an image. They take another image. They run that through image analysis software, and that'll subtract the one image from the other. And they're just left with a little dot. If that dot is there, it could be a comet, so they'll check it with somebody else. If they find the same dot and it's moved the next night, then they can work out the orbit.
Right. Well, I think that brings us nicely onto Planet X, or Nibiru, or any other name that you might want to call it. Just give us the background.
Yes, well, of course, Nibiru, this alleged, or one of the names, and actually discovered a new name recently. Hercolobus is another name for this. I hadn't come across that until recently, or Hercolobus or something.
A load of bollocks.
It sounds a bit like that, doesn't it? Yeah. So absolutely, so that the stories of Nibiru have come from various sources. The main one, to my understanding, being Zecharia Sitchin's books about called the Earth Chronicles series. He says that he's decoded the cylinder seals and the cuneiform tablets of the Sumerians, and they talk of a race of beings called the Anunnaki who came from Nibiru to the Earth, and they describe their home planet as a radiant planet, and various other characteristics about it. And they then said that this planet came close to the Earth and caused certain problems in the solar system, and then it moved. It's in a 3,600 year elliptical orbit.
Similar to a comet's orbit.
Yeah, if you look at the books, it's similar to a comet's orbit, an oval-shaped orbit rather than a circle, basically, an elliptical orbit.
Allegedly several times larger than Earth.
Yeah, I forget the exact size that the Nibiru is alleged to be according to Sitchin, but it's I think maybe a couple of times bigger than the Earth. That sort of size, at least Earth-sized, if not bigger. I forget the exact figures.
Now, if an object that size did come through an elliptical orbit, it would cause havoc with the Earth. The oceans would be jumping out onto the land, and the ice caps would be being pulled off, and all kinds of stuff. Yeah.
All kinds of things would be happening that wouldn't be very nice. Absolutely. Yeah. And people, of course, we've seen, for example, you know, various. We actually have seen an increase in the number of earthquakes. That is true. The earthquakes appear to have increased in frequency over the last 20 years. You know, for some unknown reason. I don't know the reason for it, and I don't know if anybody else does. And we've had, you know, similarly more extreme weather, which I think I know some of the reason for that. But of course, people wouldn't really want to talk about those reasons in the mainstream communities. So
just to get back to the alleged Planet X, the main sort of theory behind it comes from the Sumerian stone tablets.
Well, that I think is where it originated. But yeah.
But it's my understanding that if it does have a 3,600-year orbit, it's currently nowhere near Earth at the moment.
Right, right. I mean, Sitchin spoke about this, and I think he didn't exactly say where it was. You know, he didn't claim to know where it was, because he wasn't sure when it was last near to the inner solar system. And it's very difficult to get information about that. So he didn't sort of say that it was going to be seen in the skies at any particular point. I must stress that. However, there are a number of other websites which I've mentioned in this presentation. For example, Zeta Talk is one, and then there's Marshall Masters' website, which is YOWUSA, and there's various other websites. There's another chap called John Moore. He's talked a lot about this alleged Planet X being inbound. It's on its way in.
But they're not basing any of this on any actual evidence, Andrew, are they?
Apparently not. I mean, I had somebody write to me claiming to have I said, well, if this Planet X is in the solar system or near the solar system anywhere, please can you send me a picture? And I got this picture of a green ball.
Right, and just to go back to the Comet ISON discovery, if a Planet X is in our solar system and it's heading towards the Earth on a fairly elliptical orbit, we're going to see it maybe decades before it gets here.
Yeah, I mean, absolutely we are. And that's what I argued with this person who sent me this picture. And he claimed that this planet was, I think, 29,000 miles in diameter, and it was only 14 million miles away. Right. Which is closer than Mars. So I worked out that according to the figures that he gave me, that he said where it was, that it would be 40 times bigger in the sky than Mars is. Right. Now, you can't, obviously with your naked eye, you can't resolve Mars as a disk, but if it you would be able to if it was 40 times bigger. I mean, if you put it into a telescope with 40 times magnification, you'd be starting to resolve Mars as a disk.
Now, just give me a comment on. I've had various people email me where they've taken a photograph of the sun during the day, and they're saying, right, well, you can see there's an object there next to it, which is a small disk, and that's Nibiru or Planet X.
Yes.
Just tell us about those.
Well, most people have sent me those same sorts of images too, and there are probably two main explanations for what those images show, or possibly three main explanations. One is a lens flare, so you get, for example, light being refracted inside the multiple elements of the lenses, and then because there's a little bit of a loss of light at each element of the lens, you can end up with this effect where the bright disk of the sun gets reflected and reflected and reflected, but then the angle, depending on the angle that the sun is coming into the lens, gets slightly off center, and so you'll see an actual disk of the sun slightly offset from where the real sun is on the image, and so you get this sort of lens flare or lens reflection. That's one effect, but it looks like it could be a real object.
And if the sun was to move across the sky, would that visual artifact
that would move
as well?
Yeah, it would move.
So it would move.
Yeah, you would see that it would move, and you can see. In fact, somebody's even done a time lapse where you can see this effect.
Right.
The other effect that it can be is that some of the cheaper webcams, they have like an overexposure feature where if the image gets overexposed, the disk of the sun will appear black.
Right.
And some people have said, oh look, you can see Planet X, and you get little black disks from the reflection in the webcam lens as well, because that's also overexposed. So you'll get that. So those are two of the effects. But yeah, the third one is a sundog, where people will see you have the sun roughly in one position, then 22.5 degrees away from the sun you'll get the light refracted in cloud, and you know, I've got we'll put a picture in. I'll show you this picture I've got of a sundog, and you think it looks like another planet. It looks so weird.
And what about just touch on SOHO, which is the solar observatory, which is a probe or a craft between the Earth and the Sun, and it orbits at the same speed as the Earth, and it's monitoring the Sun. Now you can get those images online.
Right.
I've seen people claim to see Nibiru in those images.
Yes, that's right. I mean, the Nancy Lyda is one of these. She's claimed that you can see Planet X in these SOHO images. Now, of course, people can make claims of these images, and they can say, "Oh, look, you can see Planet X. That's that dot there." But if you're claiming that that's a Planet X in that image and it's of a certain size, then point your telescope at it. When of course that's not always possible because it might be in the field of view of the sun. But 6 months later, when we've moved around the sun and that's part of the sky is no longer in line with the sun, we can point the telescope at where that thing was, and if there really is a planet there, it might have moved a bit, but we should be able to see it, particularly if it's a big one. But no.
At some point it's going to be visible at night.
At some point it's going to be visible. At some point during the year, because we'll go right round the sun, so we can see all portions of the sky.
Right, okay, so we've debunked quite a bit today, Andrew. What about the 1983 IRIS probe, which was sent up and looked at the sky in infrared? And I heard that there was articles in mainstream press saying that in infrared it had seen a very large object in the outer reaches of the solar system. And I also read that scientists had measured perturbations in the movement of the outer planets, suggesting a 3 or 4 times Earth-sized objects in the outer reaches of the solar system. So,
absolutely, that's correct. And I was intrigued because I saw in the 1980s, I saw a Horizon BBC documentary. I used to watch them fairly religiously when I was that age, in those years. And they did a documentary about the IRIS probe, which, as you said, it took pictures of the sky from orbit, and it took them in the infrared.
Orbit.
Yeah, from Earth orbit. So you could see things outside, the Earth's atmosphere, and so you could look at objects which were very cool. Normally we don't get infrared radiation from space very much. In the lower atmosphere it gets all filtered out, gets absorbed in the air. So the IRIS probe could look at those cool objects. The sensor on IRIS itself had liquid nitrogen near it, so the sensor was very cool, so it could pick out these objects, and it did a great job. And then for one particular story, they discovered this sort of blob of infrared radiation on an image, and I'm not quite sure why they thought this originally, but they thought it was an object in the solar system, perhaps because it was fairly large. So they thought because it was larger, it couldn't be too far away. But as it turned out, it was actually a gas, a knot of dust in cirrus, and they didn't then report it. But the curious thing was with those stories
in another constellation.
In another constellation,
right.
yeah. I think
so nowhere near our solar system.
Nowhere in our solar system, and that was later checked.
Are you sure about that? I mean, could that not be a cover-up, or? Well,
allegedly it could be a cover-up, but again, if it was really a planet in our solar system, we would have seen it by now, because 1983 was, we're talking 20 years ago now, 30 years ago.
30 years, yeah.
My maths is going on me. 30 years ago. So we've had much better equipment which has been scanning the sky ever since. The Hubble Space Telescope. We've had sophisticated radio astronomy techniques developed now. We've had these planetoids, as I say, much smaller objects detected out towards the orbit of Pluto, better amateur equipment. So we've had all kinds of developments, but they still haven't detected this planet. And also we've had the extrasolar planets have been detected. So it would be getting hard. It's now getting harder and harder to cover up the idea that there is a planet out there. Now there still could be. In other words, there could be a planet which is way out there, quite a long way distant, way out beyond Sedna, way out beyond these other objects, and only NASA knows about it. And they've got the equipment to detect it, and they could then control that information.
Right, but if it is there, it's probably quite a long way.
Yeah, I would say it's either very small or it's a long way off.
Are there any other notable people who speak about Planet X, and if so, what's their evidence?
Yeah, well, one of the people I came across a few years ago was this alleged professor, Jim McCanney. He runs a website, I think it's called jimmccannyscience.com, and he's been putting a lot of stuff on there. He's published several books. Gets on Coast to Coast a lot. And I think he does know something about physics, and he knows something about maths, and he does have a fairly good speaking style. He appears to know some of what he's talking about. But he has also talked about uncontrollable irreversible global warming. He's into global warming and stuff like that, and he claims to be a weather expert as well. And he talks about Planet X, and he said, for example, I can read out a quote from him: far out in the solar system, actually it's not a quote, this is what he said on Coast to Coast though, this was a synopsis of what he said. He talks about Planet X type objects which could become enshrouded in clouds of dust and gas and thus be hard to see, said McCanney. But he noted that a large object could be quite visible by the time it reached Pluto. Once in this position, such an object could take hundreds of years to approach Earth, or it could come in at a super speed in a matter of weeks, he warned. So, pseudo-scientific, you know, he's not really speaking in sort of definite terms or measurements that he's made. It's just speculation. And there's no evidence that he was a professor. But he also talks about this the sun being a solar capacitor. So he talks about the sun being charged up as a capacitor, and then when a comet comes in, it discharges the solar capacitor, which sounds, you know, like the electric universe theory, but they certainly don't use that terminology. And with McCanney talking about Planet X, you know, and making these other claims, him sort of being described as a professor, but then not, and then he's talking about the electric universe, then is he, you know, sort of being put out there to discredit some of the statements of the electric universe proponents? And I think that probably yes, he is.
Right. Okay. Now, I know a lot of people are convinced by this Planet X, so I'd like to throw out a challenge. Anyone who thinks Planet X is there, send Andrew or myself the evidence, and we'll have a look at it. Can't say any more than that.
Yeah, absolutely. I mean, this is what I said to people. One chap, and he did send me some pictures, but they clearly weren't Planet X.
Right.
He said he used a green filter on a Fuji camera to photograph this thing. Right. I mean, there's no way you'd put a green filter over a digital camera to photograph a planet. You know, you're looking at it through a telescope, for heaven's sake.
Yeah, and just to push home the point that there are thousands of very, very capable amateur astronomers who are looking at the sky every night.
Yep.
So if they're not jumping up and down about it, it's probably not there.
Correct. That would be the thing that's, you know, totally swings it for me. That, in other words, NASA could cover it up, but thousands of amateurs, they would blow the whistle in a heartbeat. They want the fame that they've, you know, been trying to get for finding comets and things.
Now, what about the theory that Nibiru is actually a satellite of a red dwarf? That it's a. Have you heard that one?
I haven't particularly heard that one. I've heard that it's a radiant planet. I mean, that's what Sitchin writes about. So that, in other words, it gives off its own heat. Right. But Jupiter gives off its own heat as well.
Right. There's something much bigger. It's in orbit, and the two of them come round.
Right. Yes, I've heard that as well.
Right.
And there's another name given to it. There's also Nibiru, and then there's Tiamat, which is, I think, also. It was meant to have been a planet in this solar system, and then there's another planet which Nibiru goes around. And
that explains the formation of the asteroid belt, does it not?
Well, potentially yes. I mean, potentially there was, but possibly you could.
Because this all links into plate tectonics as well, doesn't it?
Possibly.
I mean, that's maybe another interview.
It is another interview
we can do, and it's another area of science that Andrew does not quite think we've been told the truth about.
Correct.
Right.
The formation of the Earth, or the way that the Earth has developed. But yeah, so there are stories, for example, that Nibiru crashed into another planet in our solar system and things broke off, and that's what formed the asteroid belt. Mars was the moon of another planet, and again, if you look at the orbit of Uranus, that's very unusual. Sorry, not the orbit, but the motion of Uranus, because it's tilted on its axis. So the pole of the planet is facing the sun, or facing away from the sun, rather than sort of, you know, perpendicular to the orbit. Right.
Well, let's go on to Richard Hoagland now. We've mentioned the orbit of Uranus, because where do we start with Richard Hoagland? Because we'll extend this interview because it's not on TV, Andrew. Okay, let's just roll with it. A lot of people contend that many of the NASA photographs on the surface of the moon can't possibly have been taken on the moon, and we touched on that a little bit in a previous interview. And there are some very credible researchers who have proved that some of the photographs can't have been taken on the moon, that the Apollo missions are supposed to have taken, and most of them are agreed that it's some kind of set on Earth where they've had, you know, they've had everything set up. They've maybe taken some photographs. Whether or not they went or not, that's another argument. But some of the photographs are taken on Earth. Now, there are certain artifacts in the sky or in the backdrop which point to this. But Hoagland comes up with, I would say, a third position on this. Have you?
Right. Yeah, I've come across that. Correct.
Could you just explain that, Andrew?
Well, exactly. I mean, you know, we would say from the other research that the Apollo missions, as we were showing them on the CV, you know, were not real. That's not what happened. Something else happened with the Apollo missions, and we don't really know exactly what it is. So, if you come to that conclusion, as I have, then the films that we were shown must have been faked. And again, we talked a little bit about how perhaps Stanley Kubrick was involved, but basically we were looking at a movie set.
Yeah, and I'll just put on the screen, Andrew. If you don't believe that, folks, just go and watch this show. It's the hyperlinks on the site on the page now. But carry on. Okay,
and so so basically, if we were watching a movie set, then if you, for example, were taking pictures of that movie set, and then as you, as Richard Hoagland does, you take those pictures and you turn up the contrast, and you see all these grid structures in the back of the photograph, then what are you actually seeing? Are you seeing, as Hoagland claims, these huge structures that are 3 miles high, glass domes and, you know, structures and grids and so on, or are you seeing, you know, the struts and the supports behind the black curtains that were holding up the black curtains?
Right. So, in other words, he's creating a second conspiracy to try and explain the same anomaly. Yes. And his conspiracy is that no, it was taken on the moon. It's just that those artifacts are in fact a huge glass wall on the moon.
Yes.
Right. Okay.
That's what he alleges.
He might be right. Yes. But we think there's maybe a reason why he's coming out with things like that.
Right, and I mean, it appears from what you and I have discussed before, Richard, and looking at what Richard Hoagland has put out, that he has put out some very interesting information, but then almost in the next breath, sometimes it's just utter rubbish that he'll come out with. You know, and he's done this particularly, as I've written about quite some length with Dr. Judy Wood's research. He tried to present that at a conference, and he made a number of serious errors, whereas some of it was okay, you know, but most of it was wrong. So we have to ask ourselves: is the guy, you know, is he clever? Is he dumb? Is he deliberately putting out false information to mislead people?
Right. Well, I sat through his 2011 exopolitics talk about Comet Elenin, and about how he thinks it's an artificial object, or was an artificial object, that had been launched at some point by some advanced civilization to come back to the Earth and give us all a message. And the evidence that he used to try and prove all of this, it was in numerology.
Yes.
So he was looking at times of the day that something happened and comparing that with angles that a triangle intersects a circle and this kind of stuff.
That's right. I mean, I think we gave the example, we should check this really, but he said, I think the comet was discovered at a time of 1951 in the evening. That was the alleged, either the time of discovery or the time of perihelion, the closest approach. And then he goes on to say in the next breath, well, 1951, that's 19.5, which is the hyperdimensional angle.
19.47, I think it might be.
Well, yes, it is. But
it's a hyperdimensional angle.
Hyperdimensional angle, that's what it was. And then he went on to say, and I was listening to this last night or the night before, and he said that the perihelion date was September the 11th, so therefore it had to be engineered that it was going to be perihelion on September the 11th.
Yeah, okay. I mean, yeah. Let's just... But
the problem is, I mean, people are, you know, I mean, I'm quite interested in numerology. We discussed this a bit earlier, but unless you've got some other evidence to back that up as well, you know, it's ridiculous just to do it on that basis. Unless you can show, for example, 3 or 4 amateur astronomers have photographed this comet, and they've both seen that it's got unusual characteristics compared to similar comets, but he didn't have any evidence like that.
Right. So Comet Elenin, do you know what eventually happened to it, Andrew? Did it land on planet Earth and occupants get out?
That's the thing. I think, as far as I'm aware, Comet Elenin just did what all the other comets do. I think it had a brief apparition for a few months, and then it faded away into obscurity.
Right.
As far as I'm aware, I certainly haven't seen any other evidence that anything came out of it, or you know, people have claimed that, for example, that Comet Ison changed orbit when it went past Mars. Well, not as I understand.
Ison or Elenin?
Well, Ison, you know, going back to Comet Ison, they claimed on the internet that its orbit had changed when it went past Mars because it had a close encounter with Mars. Right.
It's well, if it comes near to a large body, it will affect its path.
Yeah,
won't it?
yeah. If it was strong enough, but Mars is pretty small, so
Okay.
it wouldn't have significantly affected it.
All right. So just to wrap up then, Andrew, you would say that if there's going to be a calamitous event, it's probably going to be spotted by a whole load of amateurs months, if not years, in advance. Is that?
I'd say yeah. If you got something on the scale of anything bigger than, say, anything around the size of the moon, or even slightly smaller than the moon, you're going to see that quite a way off, and you're going to get a fair bit of warning, I think. You know, there are perhaps certain portions of the sky which are less well observed, but you know, there's enough amateurs spread around the Earth, I think, to get a fairly good tracking of most of the sky for any large objects that you know are coming in. However, you know, as was shown by Chelyabinsk earlier this year, assuming that in and of itself wasn't a staged event of some kind, which it could have been, you know, it wouldn't be that difficult for someone with, you know, space platform technology to lob something at the Earth and create this spectacle and say, there you go, you know, these asteroids are a real threat, you need to spend all this money on these early warning systems to warn people. I would not put it past some agency to have that in its plan. It would not be that difficult, even with current technology, to lob something at the Earth from, you know, not too far out in orbit and create that sort of spectacle.
Right. Maybe slingshot it around the moon or something.
Something like that. I don't know, but we, you know, as is evidenced by Tunguska, we can look at Tunguska. We don't have to read anything on the internet. We can look at the pictures from 1908. We can look at the pictures which have been taken in all the expeditions. We can see, and then we can look at Meteor Crater in Arizona. We can see that something pretty damn serious did happen there.
But I caught the end of a mainstream program talking about near-Earth objects, and they implied that you know, you might just get a sort of couple of hours warning for something which could create a lot of damage.
Yes.
Do you go along with that then? Or?
Well, I do. In terms of the mainstream, if you take the mainstream view of the technology that we have available to us, right? So the regular sort of structure of science is as we, you know, shown it in the mainstream media. The asteroid detection systems are of limited. They won't detect everything, and they won't detect everything early enough. So in other words, an object could come in that would cause some damage, and it could come in at short notice.
Right, but would so you're not saying that an amateur would probably spot that?
Not necessarily.
Right.
I think there's more chance now than there was that they would spot it, but it's still not. We could still be hit by something at any time, right, with relatively little warning. And I say at the end of this presentation that I do that if a large object suddenly did appear in the solar system, or something the size of, you know, a couple of kilometres, 3, 4, 5, 6 kilometres across, and it was headed for the Earth, there wouldn't be, with standard technology, a lot we could do about it at the moment.
Right.
We couldn't deflect it with the standard technology that we have. It would, if it was on a collision course, it would collide, you know, and that would cause a lot of damage. But again,
so you don't think they could deflect it with an energy weapon, Andrew?
I think they could, but of course they're not supposed to exist. So,
all right. So when you made that statement just now, you meant with disclosed technology.
Yes, disclosed technology, essentially. Right. Yes,
okay.
To use another phrase. So I think yes, they do. They would have any technology that they've got, you know, in Area 51 or other equivalent areas. They could probably do something to deflect that mass if it fitted in with their agenda to deflect it. Right. In other words, if they wanted to deflect it, they could. Right. So if they wanted a fairly small object to come in and wipe out a city, and it suited their agenda at that time, they knew roughly where it was going, they might just let it through, you know, just right, because it suited them. They would do that. Right. I mean, again, going back to 9/11, we know 9/11 wasn't a natural event. Somebody orchestrated that event. It didn't just happen by itself. Somebody set it up and they did the whole thing. Yeah. So what's to stop them seeing one of these objects coming in, thinking, oh yeah, we could use that, and then just let it through? Or if it's a really big one, nah, it's going to wipe us all out. We can't be having that. We'll get rid of that one.
All right then, Andrew. Thanks very much again. Brilliant as usual. It just remains for me to say, believe none of what you hear and only half of what you see. I'm Richard D. Hall. Good night.
of the things in the solar system, the relative distances. And I think without that basic knowledge, you're much more prone to being subject to victims of disinformation,
right,
which hopefully we'll get onto later. But so one of the key things that you can think of in helping to get a grasp of the size of the solar system is the distance between the Earth and the Sun, right? And many people, you know, will have a rough idea of what that is, but others don't, and the rough distance is 90 or 100 million miles. It averages at about 93 million miles. So we're going around the Sun in a circular orbit, and we average at 93 million miles away from the Sun. Now, all of the planets, you know, at different distances from the Sun, we have Mercury the closest, Venus is the next closest, often described as kind of a sister planet to the Earth because it's about the same size. Then we go out to the Earth, then to Mars, and then in between Mars and Jupiter we've got the asteroid belt, and then we've got Jupiter, Saturn, and then we've got Uranus and Neptune and Pluto. So those are the 8 planets in the solar system. They used to class Pluto as a planet.
Just to quickly interject, Andrew, am I right in thinking that all of the planets go around the Sun this way, but Venus goes around the opposite way?
That's not quite correct. The planets all orbit the Sun in the same way, but the orbit of the planets rotating on their own axis, their actual day, Venus has a motion which is called retrograde. In other words, Venus's spin is the opposite to the other planets, which is very curious, because if you think of the physics involved, you know, we've both studied physics to some degree, and we have this thing called angular momentum, and when you fire something which is spinning, or something which is spinning that breaks up, or something that is spinning changes its motion in some way, angular momentum is always conserved. So if the theory about how the solar system was formed, where they allege it's formed out of a rotating disk of material, you know, so it should all be rotating the same way. So for one planet,
Welcome to RichPlanet TV. I'm Richard D. Hall. Earlier this year I interviewed Andrew Johnson to tap into his vast knowledge of the Apollo missions and also the evidence of life on Mars. Now today I've returned to speak to Andrew, who's going to teach us some more information about our solar system and beyond. Welcome, Andrew Johnson.
Thanks for inviting me back, Richard.
Okay, now we covered the Apollo missions and Mars, as I mentioned in previous shows, and our assertions that we don't believe that NASA have been honest about what's really up there. Now we're going to talk about some more objects within the solar system, specifically comets and asteroids and this kind of thing, because you ask a mainstream scientist what is a comet or asteroid, they'll come out with a standard model or a standard view of it, and you think that it's not quite as clear cut as some astronomers might think. But before we go into comets, asteroids and other celestial bodies, for example, some people allege planets in our solar system that aren't known about, can you go through just a description of the solar system, starting from the Sun, working outwards, just to give people an idea of the sizes? I know it's quite a difficult thing to describe in 5 minutes, but...
Yeah, well, I don't think it's too bad. I mean, one of the things that struck me when you know, I started looking into this area of astronomy and some of the cover-ups, and as you said, the things that we've already discussed, was that I've been interested in astronomy for a long time, and I seem to have, know things that other people don't seem to know, which is things like the sizes of the so-called Kuiper belt, which again is meant to be something like the asteroid belt, but I think the Kuiper belt is more theorized. They can't directly observe it, I don't think, to my knowledge. It's only they've inferred its existence from the motions of various bodies which they think have come from that region of space. And then out beyond that, which is said to be some kind of limit to the solar system, is the Oort cloud. That's OORT, RT, the Oort cloud, proposed by Jan Oort, who I believe was a Danish or a Dutch astronomer, and he suggested that was where the leftover material, which was around when the solar system formed. We've got this cloud of material which is like a sphere around the disk of our solar system.
Yeah. All right. Now, one term that I've heard used is the history of the solar system, which I think is quite relevant to what we're going to talk about. And one of the things that astronomers look at to try and determine how the solar system formed and what its history was is comets. Just tell us about comets. How common are they? How many are there? How big are they? What are their orbits? How far away are they? Just give us a background on comets.
Yeah, well, this is again the excitement over Comet Ison, which was recently seen in our skies very briefly. There was lots of excitement about that, and they're claiming, as you say, that if you look at the comets, you can calculate certain things about them, you can observe certain things about them, and that will then teach you about the early solar system, because the basic idea is that comets are from the cloud of material from which the solar system formed.
Right.
Aeons ago, billions or hundreds of millions or billions of years ago.
Yeah.
And so the idea is that if you see a comet coming in, you get your telescope on it, or you do a spectrographic analysis of the tail, and you can see what chemicals are in the comet, and therefore you can see the planet to end up spinning the opposite way to all of the others. That's quite unusual. That's not easily explained by the standard.
So it doesn't go around the sun the opposite.
No, it goes round on its axis the opposite
on its
way.
axis.
Yeah,
okay.
correct.
So if we say that 93 million miles is one unit, one astronomical unit.
Correct. Yes.
How far are we talking about to Pluto, to the last?
I think it's about 40 astronomical units.
Right.
Around about that sort of figure. It's about 4 billion miles away. So in other words, one astronomical unit is roughly 100 million miles. So a billion miles is approximately 10 astronomical units.
Right. And now there are a couple of other planets, or planetoids, do people call them? Because Pluto is not a true planet, is that?
Well, they used to class Pluto as a planet up until, I can't remember when the ruling was made, but it was about 5 or 6 years ago. They decided that Pluto was too small to be called a planet, so they've characterised it either as a planetoid or a dwarf planet.
Right.
And I think you'll see both those terms used. And Pluto is actually smaller than our moon. They've now got a much better measure of its size, and I think it's about 1,000 miles in diameter, and I think the moon is like 1,400. I can't remember the exact figures off the top of my head, but it's round about those sorts of figures.
Right. So are there any other planetoids other than Pluto?
Again, that's something that seems to have been detected in the last 10 years and more. We've had several named planetoids which mainly have been detected by studies that NASA have done. One is called Sedna. That was talked about in 2003, and I think that's around about 1,000 miles in diameter. And then we have Eris. We can show some graphics of these from the websites and so on. And then we have Maki is another one, and these are all way out beyond the orbit of Pluto, so they're a long way off. And I think one of them, Eris, is 800 miles across. So these are relatively small objects. They're smaller than Pluto, but they're a long way off.
So how many times further than Pluto away from the Sun?
The Sedna planetoid, or the dwarf planet, it's 3 times further away than Pluto. So it's approximately 12 billion miles from us. It's a long way off. And the diameter is about 1,000 miles.
Right. All right. Now, within the solar system, we have other belts or bands. One after Mars, and then another one right at the edge of the solar system. Can you tell us about those, Andrew?
Right. So basically, we have the asteroid belt, which we can be fairly easily observed. I mean, even if you have, for example, a small telescope, you can't see it as a cloud of debris, but you can, for example, see some of the larger asteroids. There's Ceres and Pallas are two of the larger asteroids, which I think if you've got a good telescope and you know where to point it, you can actually see those through a telescope. And they're between the orbits of Jupiter and Mars.
And there are thousands of asteroids.
Yeah, there are thousands of asteroids. I don't know how many they've catalogued, but there are, you know, several thousand, I think, that have got names.
Right. And do these asteroids all rotate in the same orientation as the planets?
I'm pretty sure that they do. I don't think they would be orbiting in counter direction, because there would then be too many collisions.
But this zone, it's spread over a huge area between these two planets.
Yes. Yes.
And does it extend within the orbit of Mars or within the orbit of Jupiter, or is it contained?
It's contained within a relatively narrow band. I don't know what the exact width would be, but you're talking, you know, probably a few thousand miles to maybe a few tens of thousands of miles. I don't think it's much wider than that. And
I would say that the most obvious thing which would spring to my mind would be, well, were those asteroids once a single solid planet? And we'll come on to that.
We'll mention that. And some, you know, the argument has always been, as I've understood it, or is it from the asteroid belt from a planet which broke up, or from one that never formed? Right. So, you know, is it some leftover material that started to accrete into a planet and then failed for whatever reason?
Now we have a belt further out as well. Tell us about that.
Yes, these again are sketchy in my knowledge, and one is